Lesson 6.2, the Law of Cosines. This is another way to find the missing angles and missing sides in a triangle that is not a right triangle. So A, B, and C, capital letters, are going to be the measures of the angles of a triangle, and then lowercase a, b, and c are going to be the lengths of the sides opposite them. Now, there really is only one formula for the law of cosines, but this is three different ways to express it. So a squared is equal to b squared plus c squared minus 2bc times the cosine of a. And you'll notice that the other two formulas are similar, but you would be solving for b in the second equation, and you'd be solving for c in the third equation. So let's see how this works in an example. We want to solve the triangle with a equal to 118 degrees, b equal to 14, and c equal to 16. So this is what your picture is going to look like. So to solve the triangle, we want to find side A, angle C, and angle B. So since we're looking for side A, we'll use the first formula here. And a squared is equal to b squared plus c squared minus 2 times times b times c times the cosine of a. So basically what you're doing is the two sides you know, you're going to square them and add them together. The two sides you know are going to get multiplied together and multiplied by 2 and multiplied by the cosine of the angle. Make sure your calculator is in mode degrees, and you're going to punch in your numbers. So 14 squared is 196, 16 squared is 256, and then 2 times 14 times 16 is 448. The cosine of 118 degrees is this right here. And then you're going to work this out in your calculator. Just add this to this. And then, of course, you're going to be multiplying these two together. And a negative times a negative is a positive. And then you get this. So once you get to this step, you just need to take the square root, and that will give you a. So once we know what a is, we don't have to use the law of cosines anymore. We can go back to the law of sines because it's easier to use. So remembering from the previous lesson, the sine of angle B over 14 would be equal to the sine of the 118 degree angle over A, which we just found. Cross multiply, and so the sine of 118 degrees times 14 is this number right here. And then what you're going to want to do is divide both sides of the equation by 25.7. Then we have that the sine of B is equal to this, and we're going to use inverse sine, which is where you press the second sine button, once again making sure you're in mode degrees, to get the angle. Once you know the second angle, you know that there are 180 degrees in the three angles of a triangle. So just take 180 degrees minus this angle, minus the angle that they gave you, which was 118, and then that's how you can find angle C to be 33.3 degrees. In example 2, we want to solve the triangle if the three sides are given. So draw a picture, and we want to set up the law of cosines. So this time we know the sides. So just decide which one you want to find. Let's say we want to find A. Then you would be using this formula again. So a squared equals b squared plus c squared minus 2bc times the cosine of A. 11 squared is 121 plus, this will be 49, and that's going to give you 170. Then when I multiply 2 times 11 times 7, I get the 154. And then from this step, what you want to do is subtract the 170 from the 81, because we're trying to get this all by itself. So that's how I get negative 89. The next step is I want to divide the negative 89 by the negative 154. And that's going to give me this. Then I use inverse cosine to get the angle. Once again, you only need to use the law of cosines once. After that, use the law of sines. So I'm going to use the sine of angle A over side A equals the sine of B over side B, cross multiply, so 11 times the sine of 54.7 degrees is 8.9775 equals 9 times the sine of B. Divide the 8.9775 by 9, and that's how I get this. And then use the inverse sine. And the inverse sine will give you the angle measure. Once again, once you have found two angle measures, just subtract from 180 degrees to get the third angle measure. Now, an application of this, we have two airplanes leave an airport at the same time on different runways. One flies directly north at 400 miles per hour. The other airplane flies on a bearing of 75 degrees east of north. So that's how we're going to interpret this, 75 degrees east of north at 350 miles per hour. How far apart will the airplanes be after 2 hours? So here's my picture. Here's how I do the bearing east of north. So it's 75 degrees east of due north. And I want to figure out how far apart they will be. So this is 400 and this is 350. So those are the two known sides. So a squared equals b squared plus c squared minus 2bc times the cosine of a. So basically you know the included angle and then you know the two sides that form that included angle. Once again, punch in your numbers. And from here, I'm going to make sure I'm in mode degrees to get the cosine of 75 degrees. Multiply that by these numbers here. That's how, and I'm going to do that. And then I'm going to subtract from this, and that's how I get this. And then take the square root. Now I'm going to get 458.29 miles, but that's miles in 1 hour. And notice the question said, how far apart will the airplanes be after 2 hours? So take that answer you got, multiply it by 2 for 2 hours. So they will be 916.6 miles apart after 2 hours.